Where do you want to go here? Billy, let's roll. 29, everyone. Okay, 29. Find the surface area and the volume. I'll do the volume first because surface area was a little bit different here. So first, let me ask you guys, what's this figure made up of? Hemisphere and a cylinder. Okay, so let's do volume of a hemisphere. I got 4/3 pi r cubed, but I also have to remember I need to cut that in half because it is a hemisphere. Cylinder volume. Again, this fires me up if we can't get these volume formulas correct. They're on a darn sheet that you will be provided. Pi r squared times h. All right, you guys, if I need to blow it up, let me know, but hopefully that's good enough. Radius of the hemisphere is 4, so I'm just going to plug in 4 cubed, multiply that by a half. What is the radius of the cylinder? Also 4. All right, 4, there we go. And what's the height? All right, everything was given there. And then I'm going to add those two together. And that should give me the volume. Everyone all right where the numbers came from? Surface area is a little bit different. Everyone's good. All right, next up, surface area. Going to need your help again. Let's go hemisphere. Surface area is everything that is showing you can glide your hand over. What is covered up on the hemisphere? The bottom circle. So the only thing I'm going to calculate, ready, is 4 pi r squared. There is a full sphere divided by 2. Does everyone see why I'm not going to add in pi r squared in this case like we did yesterday at the end of class? We're okay there. It's covered up. Can't count it for surface area. It's covered up. And I'm not going to ask again. You already told me what the radius was. So I'm going to do 4 pi 4 squared divided by 2. So there's the hemisphere. You ready for the cylinder? What can I not count for the cylinder? A base. I cannot count. A base. So you need to do a little digging back. Lateral area of a cylinder was pi dh plus usually 2 pi r squared, but you guys just told me what? Base is being covered up, so it's just 1 pi r squared. Everyone see where all this is coming from here? Because I know we have already been quizzed on surface area, but the unit test does contain surface area still. Next Tuesday. Pi, what's the diameter, ladies and gentlemen? Diameter? 8. Height is still 5. Plus radius, still 4. And I'm going to add those together. All right. Is it we okay here? Billy, you okay? Okay, especially, I don't care about volume. Volume shouldn't be an issue. All right, but the surface area. Why I'm not adding in the circle, because it's covered. Why I'm not adding in the base. All right, here we go. Anything else we want to cover? Because we're in for it. I want to get mentally prepared. We're in for it the next 2 days. Anything else we want to cover before I come around and take a quick peek? All right, let's go. Let me see it. See the work you put in. Remember, there's only going to be 2 days of it. Density? Familiar? This year, I don't know, middle school? Density formula, mass divided by volume. All right, let's keep that in our mind for all of today and tomorrow. Density, mass divided by volume. If you can see real quick here, it's pretty easy to recognize its density because you're going to have some type of mass. And how do I know this is going to be volume? What's there? Cubed. So I see this cube there. All right, it's got to be volume, got to involve density. Here's where we're getting to today, unfortunately. Okay? The density may be in centimeters cubed, but your problem is in inches. And you can't set them equal to each other. One's got to change. That's where we're getting to today. Everything is not going to be all in the same units, okay? Instead of feet, maybe it's in inches. Instead of meters cubed, maybe the problem will be in, let's see, meters, centimeters, okay? So that's why I've given you this conversion here. And can you guys do me a favor and go back to your reference sheet as well? All these conversions are on your reference sheet. I will not give you one that's not on there. Okay, do I expect you to know, is it on there? No. Do I expect you to know 12 inches in a foot? You're darn right. Okay, that's not going to be on there, sorry. Okay, but other than that one, anything you need to convert should be on here somewhere. Okay, or I'll give it to you in the problem. Everyone good there? I'm not going to ask you to remember how many kilometers in a meter or anything like that. Okay, it'll be either given to you by the formula sheet or by me in the problem. All right, you ready to roll? Hi, Nika.
Would the regions give us anything that's not on there?
Other than, like I said, inches and feet, that's about it. Okay. They'll either do the same thing I'll do. Either give it to you on the reference sheet or they'll provide it like in a bracket or parenthesis, the conversion you need. Okay. All right, we ready? As you can see, we only have 3 problems today. Okay. 3 problems. That's because these are some big dog ones. All right. Every year they appear on the Regents and the units are never the same. Gosh darn it. All right, let's talk about our wooden cube in example 1. Each edge length, you got 6 centimeters, and your cube's got a mass of 137.8. Let's determine the density of the cube and see what type of cube you have. All right. Everyone stop. I'm not ready to do this yet. Every single problem we do today and tomorrow, and you do next week for me on the test and on the Regents in 3 weeks from Friday, by the way. 3 weeks from Friday. Good times. Every single type of density problem we do, please check yourself before you do the problem. Here's what I mean. Yeah, darn right. Check yourself before you wreck yourself. All right. See what the problem is in. What are my units for this cube? Centimeters. Check the density. What's the density in? Grams per. Okay, we're good then. Centimeters cubed, that's the same. We got to make sure they're in the same units first. If they're not, we're gonna have to figure that out come our last problem today. But for now, everyone see the cube's in centimeters. My density is in centimeters. We're good to go. I don't have to worry about it. All right. Density is, what's the formula? Mass divided by volume. All right. So density. What's the mass of a cube? 137.8. And now here's where you got to do your work. You got to find the volume. This is why we're in this unit. Volume of that cube. It's a prism. So we can do volume equals big B times H, right, for the prism. Tell me what we're going to multiply together here. Oh, boy, 25. What are we going to multiply together to find the volume? Which is the base times the height, which is also 6. There we go. So that gives me a volume of, what's that, 216? Okay, 216 centimeters cubed. I love it because we're in the same units as our density. So 216 divided by 216. Rounding directions, we haven't done one of these in a while. Thousandth. How many numbers are you going to put after the decimal? 3. By the way, if anybody has my calculator charger, I'd love it back. That'd be awesome. Somebody snagged it. 26, nearest thousandth. What do we have? Point? 3. I have that 9 rounding in the 7 up to an 8, right? Yep, and then it's grams per centimeter cubed. What type of cube do I have? I got an Ash cube, right? 0.638, 0.638. Ash cube. Yep, got to still say that because that's what part of the problem was. Find the density. Find what type of cube I have. Regent's question right there. Regent's question. Guys, good there? That wasn't too bad. Start you off nice and easy. All right, let's get a little more complicated here. Oh, look at our house. Whew, an air conditioner is going to be purchased. British thermal unit. It was on your homework the other night. Didn't you read up on that, Mason? British thermal units. We use 2.5 BTUs per cubic foot. To this value, we add an additional 1,000 for each window in the room, and there's 4 windows in this house. Or this room anyway, has 4 windows. Determine the number of BTUs to cool the room. Well, first of all, make sure we're in the same units, are we? 2.5 BTUs per cubic foot. What's the room dimensions? Feet. All right, we don't have to worry about it. Perfect. Don't have to worry about changing over units. We are going to have to find the what of our room here. Per cubic foot. That's talking about surface area, lateral area, volume. Volume. Here we go. It's going to be a volume one. What's the top in the shape of? Triangular prism. Bless you. And the bottom is a rectangular prism. Okay, here we go. Any prism, the volume is, I'm going to look at somebody here. 19, volume of any prism. Big BH. Big B is what again, everyone? Big B? Base area. What shape is the base in for a triangular prism? No, you're going to tell me?
Okay, I found this on the web. For what shape is the base in for a triangular? Check it out.
All right, I'll check it out later, Siri. All right. It's a triangle. What are you going to use to find big B then? Here you go, 14. What are you going to use to find big B? What formula? Okay, everyone ready? 1/2, keep going. Sorry to cut you off there, Caleb. Base times height. So everyone take one of these triangles right now. What's the base length? 18 times the height of that triangle. 6. Now, what's this H stand for? Height of the prism. So you need to find me how long is that edge that connects the triangles? Because that's the height of the prism. How long is that edge that connects the 2 triangular bases? 7, great job. 12, where is it? 24. Everyone all right there? 8, go ahead.
So I still don't really get why the 24 would be the height.
Because this is the volume of the prism is the area of its base times its height, the prism's height. So as I go prism's height, the height's always the edge that connects the bases. Okay? Because I can do it like this. I can turn it up where the triangles are on the top and the bottom. The height's going to be that edge. Okay? Everyone else, we all right? All right, so what is the volume of your prism here? (26) volume of the prism. Triangular prism, excuse me. 1,296 cubic feet. I like it. All right, let's go to the rectangular prism now. Still BH. How do you find the area of its base now? Who's up? Who's up? 12, area of the base of the rectangular prism. Darn right I do. 24 times 18 times the height, which is the 9. We are filling up the inside. So what's covered up does not matter. That's for what? Window surface area, we care about what's being covered. Volume, we could care less what's being covered up because I fill up the inside, not the outside. So we're getting 3,888 here, cubic feet. And then what am I going to do to the two to find the volume of the room? Go ahead, add them up, everyone. Add them up. So your total volume, 5,184 cubic feet. For every cubic foot, I got 2.5 BTUs. I'm just tired of, I don't know, multiply, divide. I'm just going to guess. You don't need to guess. What can we set up? If you're wondering, set up a darn proportion that says the following. Ready? 1 cubic foot. How many BTUs do I need? 2.5 BTUs. Where do I place the 5,184 now? $14. Where should I place the 4,184? On top, across from the feet. Feet go with feet. So I do end up multiplying that by 2.5. And what do you guys get in there? 560. $5,184 times 2.5. I have 12,960. Not there yet. Not there yet. What still do we have to integrate? What do you got, Thomas? What did I forget about? I read it at the beginning, but skipped my mind. How many windows? 4 windows, and how many BTUs for every window? So 4 times 1,000, got to add in. 4 windows, 1,000 BTUs apiece. So in total, we're going to need 16,960 BTUs. That's where we are now in the unit, guys. Sorry. That's where, and I'm not sorry. What am I apologizing for? This is where we are. Anything you want to ask before we get to this last one? And it's 2 days of this, 2 days. We got more practice tomorrow, less of me up here, more of you practicing tomorrow. All right, let's get to it. Last one. All right, here you go, guys. Ready? I got bricks, 500 of them. Each brick, 5.1 by 10.2 by 20.3 centimeters. The density of the brick is 1,000, kilograms per meters cubed. My trailer can only hold 900 kilograms. Can the trailer hold the weight of 500 bricks? Okay, right away. Anybody see anything we got to pay attention to? What do we see here? What's the bricks in? Centimeters, and what's my density in? Got to do something here before I calculate, before I start plugging it in. What do you got, Anthony? I am going to recommend right now that you do it beforehand, yes. Here's why, everyone. Take a look. Please do not write any of this down. You start doing D equals mass divided by volume. You plug in the 1920 for the density. You plug in the mass, which is what we're trying to find. And then you do volume, but your volume is going to be in cubic centimeters. You can't set that up, okay? Because this is in meters cubed, that's centimeters. We need it all the same. So Anthony just asked, when should I convert? When I find the volume or at the beginning? Do it at the beginning. Okay? And this is one where I will give you, I don't know, is that on your formula sheet? Centimeters to meters? Okay, that's fine. Here you go. 1 meter, anybody know this? 100 centimeters. Okay, 1 meter equals 100 centimeters. Okay, so what do I do to convert it? I got 5.1 centimeters. How do I convert that to meters? Okay, and I see the wheels are spinning. I'm not really too sure. Do I multiply by 100? Do I divide by 100? I don't know. What can we still set up? A quick proportion that says the following. 1 meter off to the side equals 100 centimeters. Where do I put my, what was that? I just erased it. 5.1. On the bottom with the centimeters. And that should answer your question really quick. Do you multiply or divide by 100? Divide it by 100. So everyone take 5.1, divide by 100, and we end up with how many meters? 0.051 meters. Got it? Keep going. Do it to the 10.2. You don't need to set up another proportion. You know you got to divide now. So 0.102 meters. And then what about your 20.3? 0.203 meters. Got it. Okay, you ready? Okay, now I got everything in meters. Love it. Density equals mass divided by volume. What are you going to plug in for D now? 1920. The mass is what we're trying to find because I want to find the mass of one of the bricks to see if this trailer can hold 500 of them. I want to find the mass of one of the bricks. And then what about the volume of a brick? Haven't done it yet. Haven't done it yet. Let's calculate the volume of the brick. Looks like it's a brick's a rectangular prism. What are you multiplying together to find the volume of the brick? 12. What do you got? There it is. Yep, we're getting a little decimal here. Can't round it though. I'm getting 0.001056,006 meters cubed. Just check my work too. So that goes into for the volume. 0.0. And again, these have to be the same. Meters, meters. Can't have centimeters and meters. And then what are you going to do here to your equation / proportion to find the mass of a brick? Multiply them out. Yep, multiply them. About what? About how many kilograms per brick? 2.02753152. And what units is this in? Look at your density. Look at your density. What units is this in? This is mass, kilograms. Okay, now that I know one brick is about 2 kilograms, how do I figure out if the truck can hold it or not? Well, how many bricks do I have? 500. So let's multiply this by 500. So 500 bricks is about, I think it doesn't really matter if we round or not. We can tell if the truck's going to fit it, right? Because it's about what, 1,014 kilograms you're getting? So what can we say here? You need a bigger truck, right? Trailer cannot hold 500 bricks. Because what was its capacity? 900, yep. Trailer cannot hold 500 bricks. Cannot hold, there we go. Okay. I do not give up on the last one tonight with the snow cone. Okay, do not give up on the last one tonight with the snow cone. All right. I'm just letting you know, the last one with the snow cone, there's a change in units, so be careful, please. All right, just be careful. There's a change in units. And let me just make sure. I don't know if I gave you the, because it's grams, it's a kilograms. Is that on the formula sheet, Emma? What do you think? Grams to kilograms? Nope. Go to number 4 real quick, please. I should have provided you with the conversion for number 4. 1 kilogram. Here's the conversion for number 4. 1 kilogram equals, anybody know how many grams? 1,000. Okay, because you'll notice it changes from grams to kilograms in the problem. So 1 kilogram equals 1,000 grams. Do not give up on it. Do not give up on the wax mold one, the candle one too, at the bottom of your page. All right, you guys can start it. We're not going to do a region problem today. You guys can start that